12, whenever you are doing a combination, doing 12, choose 7, you are going to have 12 factorial in the top, but what goes in the bottom? On a combination, you have 2 numbers. What are the 2 numbers? Not 7 and 12. 7 and 7 plus what gives me 12? 5. So whenever you are doing a combination, always remember the 2 numbers on the bottom combine to the top. And so on this one, again, we would expand 12 all the way down to 1. Now on the bottom, I'm expanding first 7 down to 1, and then 5 to 1. All right, let's see. How much of this can we cancel out? Ooh, I think more than 5 to 1. All right, the 7 to 1 here can cancel out with the 7 to 1 here. Now, remember whenever we did some combinations with some stuff to make them smaller? Do any of these numbers left over? Could I multiply any of these numbers to the top numbers? Like what?
5 and 2.
What do 5 and 2 multiply to?
10.
So, is everyone okay if 5 times 2 is 10? I can mark out this 10 as long as I mark out the 5 and the 2. What about the 4 and the 3? Do they multiply to anything? All right, so what's left? You get the same answer. It's like you have to simplify. You'll have to do an extra step of division later. It's this. You'll get the same thing. So on this one, what's left is 11 times 9 times 8. Those are the only 3 numbers left, right?
Yeah.
What do we get?
792. Oh.
All right, so remember, in a permutation, order matters. So all of those combinations of 7 where you would have the same thing, whenever you do a combination, it takes out those repeats where whenever they're in a different order, they still mean the same thing in a combination. So we have 792. Now, on 3 and 4, I'm not going to go through these completely, but I want to at least get you started. So whenever you are looking at a problem, you have to make the decision if it's a permutation or a combination. So if we look at number 3, 11 people entered the fair contest. How many ways can you arrange first, second, and third place? If you guys look at this, does order matter? Yes or no?
Yes.
If they have certain first place, second place, third place, you don't think order matters there?
Yeah, it does.
Absolutely. First place is different than second place. Second place is different than third place. So on this one, order matters. So is that a permutation or a combination?
Permutation.
All right, this is a permutation. What's the total number? How many am I picking? 3 places. So then you would just do this. And that's where I'm going to stop there. So you know it's a permutation. There's 11 people total. You're only picking 3 places. Now look at the second, or the last example for this lesson, number 4. All right, so I don't know about you guys, but I really, really like appetizers. And I never can make a decision, so I like getting samplers where I can get a little bit of everything. All right, so if I order an appetizer sampler at a restaurant, if there are 10 total appetizers and I can select 4, how many possible samplers could I make? All right, is this a permutation or a combination? All right, I'm just picking 4. When they put them on the plate, I don't know which one they plate first. They're just putting them all together. So on this one, this is a combination. How many total appetizers are there? How many am I choosing? So on this one, it would be 10 factorial on top, and then on bottom, it would be 4 factorial, and then 4 plus 6 gives me the 10, and then I would go from there. All right, do you guys have any other questions on permutations and combinations? I promise there will be no surprise questions tomorrow on the test. They will be very similar to these. Like I might not be doing appetizers, I might be picking something else. And it might not be the same, like it'll be different numbers, but the same type of question. All right, now let's look at number 2, or the second lesson. Just simple probability. Do you guys feel comfortable with a question like this? A bucket contains 15 blue pins, 35 black pins, and 40 red pins. And you are picking a pin at random. And I want to know like the probability of black, the probability of blue or red, and not a blue. What do you have to find out before you can answer any of these questions? Okay, how many total pins are there? What's 15 plus 35 plus 40? All right, so before you answer this, you have to know that there's 90 total because that's going to be helpful. So do you guys agree the probability of a black pin would be 35 out of 90?
Yeah.
And if I took 35 divided by 90, I would get 0.389. All right, now what about blue or red? What would you do there?
Add the blue and red pins together out of 90.
All right, so blue pins is 15, red pins is 40 out of 90. So do you guys agree 55 out of 90? And if I divide that, there's my decimal. All right, what about not a blue? Okay, so some of you might think there's 90 and minus out the blue, right? Oh, that blue is 15, not 40. Which would give you 75 out of 90, right? What's another way that you could have thought about this? If it's not a blue pin, what colors are we talking about?
You just subtract 15 from 90.
Okay, that's what I did here. I subtracted 15 from 90, but what would be another way of thinking of, if it's not blue, what colors am I talking about? All right, now if I add black, which is 35, and red, which is 40, do I still get 75 out of 90? All right, I don't care which way you do that. But no matter what, you're going to get 0.833. Let me zoom in a little bit so you guys can see those a little better. All right, how do you guys feel about a question like that? All right, any other questions on this page? All right, let's take a look at the next page. All right, the next one we're talking about cards. I will be giving you guys an image that has a list of all 52 cards. So it'll have all of the cards to help you count. If you guys have that, do you guys feel like you could answer these questions a little better? Lane, do you feel like you could answer questions better if I give you all 52 cards in a picture?
No. I already know more.
Why not?
Because I know it's 52.
Well, that's what, like, if you see probability of a heart, if I have all 52 cards, you can simply count how many hearts there are. I feel like that I don't want to put you guys at a disadvantage if you're not comfortable, if you're not playing a lot of cards and you don't know.
Well, actually, I don't even know how many. I think there's like 12 in there.
There's 13.
Okay.
So
Okay.
that's what, if I give you guys the list though, I feel like you guys can see that a little better. And so I found an image that I thought would be helpful. So on this one, and first of all, let's think about this. How many suits are there? There's hearts, diamonds, and what else? Spades and clubs. So there's 4. So a heart, there's 13 out of the entire 52, or 1 out of 4. All right, now the face cards are jacks, queens, and kings. So that's actually 12 out of 52, or 3 out of 13, if we reduce it. And then not a queen. How many queens are there?
4.
There's 4 queens. So if it's not a queen, we would do 52 minus 4, which is 48. 48 out of 52 reduces to 12 out of 13. That's all you have to do on those. And I will have an image to go with it. Does that sound good?
Yeah.
All right, probability of multiple events. All right, if I'm rolling a dice, or a single die, a fair number cube is a die. I have the option of rolling a 1, a 2, a 3, a 4, a 5, or a 6. That's what we call the sample space. So how many of these 6 are an even or a 3? Even or 3, how many are we looking at? All right, even numbers are 2, 4, 6, right? And then a 3. And I'll say if you guys need, so we've got our evens or our 3, so that's 4 out of 6, or 2/3. All right, what about less than 3? What numbers are less than 3? 1 and 2, so how many is that? 2 out of 6, or 1/3. All right, now the last part, 1, 2, 3, 4, 5, 6, prime or 4. What are the prime numbers here? 1, 3, and 5, but there's actually one more prime number. 2, or a 4. How many is that? 5 out of 6, and you can't reduce it. I promise there will be a dice question tomorrow. I'm not rolling 2, I'm going to do single dice. Single die. All right. Now, I want you guys to look at numbers 14 and 15. All right, so students can either participate in baseball or golf. Does it say that they can do both?
No.
No. They're either doing one or the other. So these are what we call mutually exclusive. They cannot happen at the same time. So the probability that they are participating in one or the other, whenever we see the word or, do we add or multiply? Oh, I don't think so. We add. Think about this. Whenever we looked up here, we didn't multiply these. There were 4 primes and 1 number there, and we just added 4 plus 1 and got 5. Or means add. So the probability of baseball, what's the decimal for 11%? 0.11. What's the decimal for 8% for golf? 0.08. So if I add those together, we get 0.19. All right, now on this next one, I want you to see, are these mutually exclusive? It says, what's the probability that selecting a shape is black or has 4 points? Are there any shapes that have 4 points and are black? Okay, so remember, whenever we have things that are not mutually exclusive that can happen, you're going to add the number of black, you're going to add the number of 4 points, but then remember we can't count some of those twice, so we subtract out when it's both. All right, so first of all, how many total shapes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to add the black, add the 4 points, and then subtract where it's both. So how many of these shapes are black? 9. All right, how many of them have 4 points all together? 4 points are these little weird looking ninja star things. You guys agree there's 4? 1, 2, 3, 4. So when you add 9 plus 4, that's 13. You know that you can't have 13 out of 10. You subtract out the ones that are both. How many are both the ninja star shape and black? Three. All right, so what is 13 minus 3? And 10 out of 10 is 1. Now I want you to look at this. There's only one shape there, correct? That is white. So all of these are black. This one is the 4 point, so it included everything, so that's why it's 1. Now I will give you guys the probability of this. I will give you guys the formulas. So I will say, like, if it's mutually exclusive, you add these. If it's not mutually exclusive, you add the 2 together and subtract out where it's both. I will have that up there on the list with the permutations and the combinations formula. All right, and then we moved on. This was probably, I gave you guys participation for these, but we've got to talk about these tables. If you guys look at this, this line here means given, and the second one is always the one that is given, the one that you know. So the first thing you would have to do here is what's missing in our table. You know, say, I'm telling you the type of guitars and the color of the guitars, but what's missing? All right, if it's not there, you're going to have to put the totals in. So let's see, let's add 78 plus 34 plus 12. All right, that gives me 124. 42 plus 56 plus 16 is 114. And then I'm going to make my totals for each color. So 78 plus 42 gives me the total number of 10. 34 plus 56 gives me the total number of black. And 12 plus 16 is the total number of blue. So on this one it says, what's the probability that it's a black guitar given that it's acoustic? Which one do we know? Do we know the second one is always the given one? So what do we know about this guitar? Is it black or is it acoustic? All right, the second one is the one you know. All right, so we know it's acoustic. So we are only looking at the acoustic numbers. So ignore the electric numbers for a second. So if you look at this, how many of them are black? How many total acoustic guitars do we have? So this one is 34 out of 124. Divide that, and it gives you 0.274. So this is the one we know, so we're going to do the total acoustic guitars here. Then in that acoustic, how many of them are black? 34. Now on the second one, what do we know about the guitar? The second one is the one we always know. I want to know, what's the probability it's electric when I know it's a blue guitar? So how many blue guitars are there? We're only looking at the blue. So this time it's a row. How many blue guitars are there? All right, there are 28. Now, out of that 28, how many of them are electric? Is it 12 or is it 16? 16 out of 28. All right, and then last but not least, what do we know about this number 18? Is it acoustic or is it tan? All right, this is the one we know. So we're only looking at the tan, and since it is a color, we're only looking at the tan row. All right, how many total tan guitars are there? 120. Now, out of that 120, how many of them are acoustic? 78. And we get 0.65. So whenever you guys are looking at those, the second number is the one that you look at, that information only. So on that first one, when it was acoustic, we ignored the electrics and we only looked at this acoustic column. Then if the given is the other side, if it's a row, so like on that next one, we only looked at the blue row. When it was tan, we only looked at the tan row. I'm going to say, guys, we still have time. I don't know why you guys are cleaning up. I have 8 minutes left. All right. Then we moved on, and you see here where I tell you, make a tree. All right, so if you look at this survey, all right, I'm asking a group of juniors and seniors to fill out the survey, and it tells me 52 of the responses came from juniors and the 48% came from seniors. That's my first part of my tree. All right, so the first thing I know is they're either a junior or a senior. Now, what do I put here? I do the probability. So what decimal am I going to put here for juniors? 0.52. And what am I going to write for seniors? 0.48. Now the second part, it says 60% of juniors have a part-time job. So out of the juniors, I have two options here. They either have a job or they don't have a job, right? 0.6 and 0.4. 60% of them have jobs, so that means 40% of them don't. Now what about seniors? Same thing. They can either have a job or not have a job. 0.72, and then where'd you get the 0.28 from? All right, yep, 28 out of 100, because if 72 do, 100 minus 72 gives you 28. So when it says junior and no job, and is whenever you multiply. So what's my probability of being a junior? 0.52, and then what am I going to multiply that by? No job. 0.4. 0.52 times 0.4 gives me 0.208. Now what about senior and no job? What am I going to multiply?
0.48 times 0.28.
Senior, no job, 0.48, 0.28. And I got this. 0.1344. All right, now this is the one, like not very many people got this one right whenever I looked through. All right, I just found out this number that you found here was no job, juniors with no job, right? And this is seniors with no job. So if I just want the probability of anybody without a job, what am I going to do to those two numbers? No. Add. You're just finding the total. You've got your juniors and your seniors would give you a total. So you're going to add your juniors without a job and your seniors without a job. And this will give you a total number of people without a job. And I promise if I ask you a question like this, you will have the numbers above to put together. All right, and then I don't want to spend a ton of time on this last part because you guys did really well on this assignment when I looked at these yesterday, for those of you that turned it in. Do you guys have any questions on mean, median, and mode? You know, say, I felt like you guys did great on the mean, median, mode. So I don't, unless you guys have a specific question, you know, say make sure you put them in order. I'm not going to go through this one in detail. Now, what about the 5-number summary and making the box plot? I think a lot of you just didn't like, the only thing that hurt you guys on the assignment yesterday when I graded it, a lot of you just didn't make the box plots. Like, you told me these 5 numbers and then you quit. So do we need to go through that? Okay, I see some people saying yes. So in order to do this one, we have to put these in order. So let's see, what's the smallest number? 2? And there's only one of those. All right, how many 3s do we have? 2 3s. And we've got 2 4s. We've got a 5 and a 6, 2 7s, an 8, a 9, 10, an 11 and a 13. Oh shoot, 15, 17, 21. I kind of went out of order. All right, minimum is 2, maximum's 21, smallest and biggest. Median is the middle. So if I start from the edges and I go to the middle, there's a true median. That 7 is exactly in the middle.
Is there gonna be like ones that aren't, you don't have to do like a 5, you just have to do a median mode?
There will be some that's mean, median, mode, and then there will be some that's a 5-number summary in the box plot. Hey guys, how do we find Q1? What do we find the median of? All right, the lower half here. So the median there, we start here, work our way in. These 4 split the middle, so it's just 4. Now here, the 11 and the 13 split the middle, so what would I write there? What's the yep, so we would do 12. So then to make our box plot, the 3 numbers in the middle make the box. So we would go from 4, make another mark at 7, make another mark at 12, and that makes our box. And then our whiskers go to the minimum, which is 2, and the max, which is 21.